Hello. Hello, good afternoon to everyone, and thank you for being here. It's not working? Yeah.
Yes, this is working.
Okay, that's fine. Thank you. So thank you for being here. I think you will have a very long afternoon session because there is no coffee break. So we are well behind the schedule. So I will try to push a little bit our presentation. So I will try to present the panel. The panel is some experts who are working in the hydrogen mobility. And the first idea is we are working in an administration research body, so I can make the approach from a research point of view. We have some consultant that it will give you some insights, how will be the strategy for the consultancy point of view. And to finish, we have another two more colleagues. One of them will give you the approach from a region for La France. And the other one it will be showing you some examples on how to approach this energy transition in order not to do what I was trying to present to you. So only first question, we are working in a national research center in Spain. It has been starting in 2007. We are more or less 65, 66 people and working in the hydrogen and fuel cells. So we are covering the whole value chain of this sector. And this means that this is the capabilities we have. As you can see, that every line from the value chain of the hydrogen it will be also covered with a different dedicated lab. And this is the strategy we have. So you can see that we are working not only in the production of the hydrogen, but also how to store, how to transfer into the energy again, how to go to the different applications, not only mobility, but also the stationary, and also working in the safety and standards and in the cross-cutting issues that you know that there is a very big, huge box that you can start working in all the different value chain. In order to give you some a few projects, we are all going and try to say that is the traditional approach to use the hydrogen in mobility. This is one European project. The first one who are using the hydrogen for the logistics of the port is called the H2 port, and is in a port in Spain, in Valencia. That is the Mediterranean coast, and where we are trying to develop two different machines that is working with the hydrogen in order to decarbonize the area of the working in the ports. Another project is also with the Chilean guys that is similar to the previous project that he has been already shared. That is trying to develop a hydrogen machine for the underground mining. You can have here another project who is the train. This is C2H2 rail. This is the developer of a hydrogen train, an hybridization with the batteries, of course. And this is a project where it is not only concentrated developing the train, when you not working. And I think it's only one more left. Yeah, you have a H2 login. This is a project where we are trying to work with a local and Spanish supplier in order to working and develop the garbage truck. Who also is a vehicle, the traditional vehicle, in order to use this hydrogen, and also another platform that is also trying to develop the different capabilities of the use of the hydrogen in order to develop not only the truck, but also a platform who can to be used in a different applications. And I think this should be also one app. This is free of charge. We have been developed in the center in order you to have this uploaded in the mobile and try to see how will be the trip from the hydrogen when you are using this hydrogen vehicle instead of the vehicle you are driving. And the last slide is another project which is called H2 Area, where we are working in how to define the different blending of the gases within the network in Spain in order to have the loop and try to have this for testing and try to define the different conditions. And I think this is the last one. So I promise it will be quick. I don't know if it's as quick as I promised him before, but the next speaker will be Jean-Luc Chabadie. Is the consultancy working Capgemini, and he will give us some also approach how to be the different strategy when you are talking about the hydrogen to be used in the mobility. So Jean-Luc, what do you have?
Okay, thank you, Emilio. So first, where's the this one? Okay, doesn't work. Demo effect. Okay, so it's 5:37. I got and you got lots of valuable information since this morning. So let me try to verify if you are with us. Diesel is the future of mobility. No reaction. Are you there? No, diesel is not the future of mobility. Hydrogen is the unique solution for decarbonized and sustainable mobility. No, neither. Not for all the use cases and not for everybody and not for everywhere. Let me elaborate a little bit on that. So I'm part of Capgemini Engineering. So maybe you ask what Capgemini is here on the stage. Is Capgemini International Research Center, like Emilio? No. Is Capgemini producing cars, like Fauzi? No. Is Capgemini producing, distributing hydrogen, like Sébastien? No. So who we are? We are Capgemini Engineering, 70,000 engineers, part of Capgemini Group. And we are working on any stage of the value chain, from solar to car, trains, aircraft, fuel cell, electrolyzer, pipelines, and so on. So we are engineers. We also have some vision capabilities, and our job is to support our clients when they are facing tremendous challenges to achieve decarbonized mobility. Okay? So we are focused on product and system engineering, digital and software. This is very important, and I'll come back sometimes. Data is everywhere, and data just requires to be valorized. Is it easy? No. And Capgemini also addresses industrial operations, and I'll come back a little bit later on that. Morocco. You all know that automotive sector is crucial, very important for this country, as it is for Capgemini. And so naturally, we are growing fast in Morocco. So we are nowadays more than 3,800 consultant engineers here, really focused on automotive, not only focused on automotive. And when considering automotive, we do have to have a vision where this sector is going. And we have to tackle the mobility and decarbonized challenges. Let me share some parts of my conclusions. First, TCO is key. It's not just a question of designing the best product, a car or a train, whatever. You have to consider the economical domain, economical aspects. So don't confuse feasibility and viability. Don't forget that you have to align two galaxies, the energy and the automotive, for the subject of today. And those galaxies are full of planets. Some planets are very close. Some planets can be easily aligned, some not at all. You will have to make choices. You have to be pragmatic. You have to build roadmaps, maybe starting with a solution which is not perfect, but which is there, preparing the future and avoiding to embrace all the scope at the same time. And let me try to illustrate what I'm saying. I think you all know this kind of diagram. It's quite old, 4 years, I think. Interesting to see what the perception of those experts 4 years ago. They consider that taxi has to be considered differently as personal car. Is this still the case? Yes. That small cars are very different from medium and large. Buses is not a coach, is not a truck. Bus goes inside the city, truck mainly outside of it. Okay? And the key is captive fleet and intensive usage fleet. And the best is to have both captive and intensive usage fleet. And since the beginning, the heavy duty has been considered out of the pure hydrogen mainstream and connected to the synthetic fuel. But there was no consideration of the hydrogen internal combustion engine. And we'll come back on that. So, very different roadmaps. Let's have a little look on what's going on at the vehicle stage. So, why different roadmaps? First of all, we are driven by the regulation. And it has been explained this morning, this is very important, to focus and drive and push the market. And as you know, the CO2 objectives for the aviation, for the naval sector, for the trains, for the cars, for the bus are different. And Europe has been very prescriptive. So objectives are different. So it's normal that the reactions are different. The price of the fuel cell. And there we have one chicken and egg effect. We have some others. Not that many cars, so not that many fuel cells, so expensive. You know that they are integrating some rare and expensive materials, but when you don't have the volume, normally you don't have the price neither. So the consideration at the vehicle level, as you know, a hydrogen system is a little bit complex. Okay, you have different components, and sometimes, most of the time, devil is hiding onto details, and the chain relies on the weakest part. And sometimes fuel cell is not the weakest part of the chain. So fuel cell is a complex system, an expensive system. The vehicle at vehicle level is complex too. So when considering the fleet, it's very, very complex. And when you're integrating the energy, it's more complex. Performances. Performances in terms of how to manage the hydrogen system. You know that it's complex. You always have a battery, you have a fuel cell. Sometimes the fuel cell is a range extender, sometimes the main source, depending. But anyway, depending on the way the driver is behaving, depending the external consideration, the performance and effectiveness can change a lot. And you have to manage that. The payload, the weight, and the volume. And I have well, I don't know where is the pointer. Okay, the graphic with the green circles. It's a classical graphic when you compare the energy per mass or energy per volume of hydrogen compared to other fuels. So hydrogen is very good. The ratio energy versus weight is very good. Versus volume, not that good. But it's the molecule. When you consider the tank, ooh, going to the left. And so that means that as part of the payload, the tank, the reservoir is really a technical issue. And this morning, for example, I've seen that Forvia announced in Korea a new big reservoir, 700 bars for trucks. And we'll see afterwards, the current architectures are mainly based off several reservoirs, several tanks, adding complexity, leakage probability, and so on. So lot of technical challenges. Competition with BEV. I wrote competition, but I don't think this is a proper word. Co-petition. Hydrogen, when considering FCV, it's an electrical car. So there is no real competition with the battery because first you will always have a battery, and the hydrogen for the fuel cell for the FCV is a solution to mitigate the limitation of the BEVs, which are autonomy and the time to refill. So if you have a car running just inside the city, 100 kilometers per day, probably hydrogen is not a good solution. When you have a truck, 40 tons, battery is not a solution at all. And buses in the middle. Okay. And as I said before, by this time we did not consider ICE, so burning hydrogen inside a thermal engine, which is nowadays more and more an investigative solution when looking to the Asia, which is a place of the world where things are moving very, very fast. So what's in common? The main factors: total cost of ownership. It's not automotive sector, but on the railways, you got the information 3 weeks ago that one of the lenders in Germany that bought the Alstom hydrogen train decided to stop. Not because the train was not working. It's a beautiful product. Not because there were some hydrogen distribution issues, no, because of the cost when compared to the electrical train. And so you have to anticipate that, else you're going to have some bad surprises. And this is obvious. A hydrogen car needs hydrogen. You need to have the volume of hydrogen you need, where you need, and the price which is affordable. Sometimes a more expensive solution is interesting when you control the price. And I don't think the word sovereignty has been pronounced this morning, but regarding hydrogen and this capability to generate and store energy, this is an important factor. The solution may be more expensive, but it's stable and you control more than if you import energy from the outside. Deep dive. Be careful not to be disturbed by the demonstrations. There are lots of demos. Europe is putting lots of money on the table. Lots of hydrogen vehicles are running onto different cities, but it's demo. When coming onto the real world, sometimes there are very bad surprises. The cost of the hydrogen distribution network, you have a graph there. I don't know, I'm not sure it's visible, but the three colors are liquid hydrogen, pipelines, or trucks. Maybe you've seen that in Asia, Toyota is starting to experiment liquid hydrogen inside the cars. Okay. Two interesting graphs over there. So you have that when downloading the presentation. On the top here, you have the hydrogen European backbone. So the thing that Europe wants to reuse pipelines used for natural gas to transport hydrogen. Interesting map. And there you have the European network for the trucks, the RTE. And so the first approach, you can say, oh, this is good. So for the trucks, we'll use the pipelines. Not that simple. Because in pipeline, you won't have pure hydrogen. You have part of methane. You have to extract, so complex. Okay, possible, but be careful about the variability. And again, a distribution station is not a simple object, not at all. It's not like for the fuel. Okay, you have to cryogenic -40 the hydrogen. It's a complex animal. Some data going quickly. So the network, so RTE Central Europe plans to have 1 refill station per 200 kilometers in 2031. You have Europe map, every 200 kilometers, 1 station. For ISEA, this station needs to provide 6 tons of H2 per day. Currently, Europe is investing in refill stations to deploy 67 units. The subsidies are 110 million euros. and global budget probably multiplied by 4 or 5. That won't be simple. You have a lot of leakages. The transport costs a lot, even though it appears to be cheap, like in pipelines. And the tank, okay? At 700 bars, you transport 55 grams of hydrogen per kilo of tank. This is why there are some interesting studies and R&I on the tanks, materials, and so on. In terms of concrete examples, BMW Series 5, 6 kilograms of H2 for about 500 kilometers, roughly 1 kilogram of hydrogen per 100 kilometer. For a bus, it's multiplied by 10. Single fuel cell has around 300 sensors. So at the vehicle level, you can imagine, at the fleet level, you can imagine. So this is why I'm saying there are lots of data. Yeah. Autonomy can drop by 20% depending the way you drive the vehicle. Conclusion. Feasibility has to cope with market expectations, which are currently driven by regulation. Be careful not to be prisoner trapped by the EU vision. In other part of the world, in the US, in Asia, vision is different. And the thermal engines that we are planning to ban are very welcomed on this kind of country. TCO is key. Energy and mobility have to align. Considering everybody on the value chain wants to verticalize the value chain. I'm producing tanks, I want to run the control command. I'm producing a car, I want to have the fuel cell. So the journey is a roadmap where you have to choose the best option, available option, BEV, FCV, RC, sometimes brand new, sometimes retrofit, sometimes IC with 100% hydrogen, sometimes a mix of. H2 engineering is rare, experience is rare, notably in the automotive sector. And lots of data are available, but not accessible because of conflict of IP and so on. So at the end, conclusion, this is greenfield for cost and system engineering, leading in technologies to predict at design phase, to predict the operations, and new kind of services like predictive maintenance and so on. I'm sorry, I've been a little bit long. It's always the case. Thanks a lot.
Well, thank you, Jean-Louis. Now is the time for a region approach. It will be Benjamin Febvre, who will be also share with us how will be L'Occitanie. He was also presenting the strategy of the hydrogen. So the floor is yours.
Thank you. I have a slide, only one slide. My name is Benjamin Febvre. I'm working for the Business Development Agency of Occitanie region. You can see where is Occitanie. It's the red area in the south part of France, between Pyrenees Mountain and Mediterranean Sea, with the city of Toulouse and Montpellier. We have in Occitanie, and the project I want to present you today is a part of this support plan, a dedicated support plan for hydrogen development and development of all the hydrogen sectors. We have 5 issues in this support plan and a budget of 150 million euros for the next 10 years dedicated to supporting hydrogen project for produce, refuel, store hydrogen, project for use hydrogen, and we are able today to help people who want to have vehicles, and also we want to show the example. And for example, we invest in hydrogen trains developed by Alstom, in hydrogen coaches developed by the regional company Safra, and also investing in the building of a dredge boat. So everywhere we can, we want to show the example. We have other part, and it's very important, the territorial approach and also the anticipation of training needs is a huge part of this plan, and we want to anticipate it. But what I want to show you today is one of our flagship projects for the fourth objective to become a European leader, and to share with you the story of Corridor H2. At the beginning, it was in 2019, we changed with other territories in Europe, in Spain, in Belgium, in the Netherlands, and other French region also. And we say today we have an ecosystemic approach. We deploy a production, a refueling station, and vehicles in a small geographical area. Today, we want to address trucks. How is it possible? We asked to the carriers, and they say, according to us, we need to have a network of refueling station. If we don't have a network every maybe 100 kilometers, that's not possible for us to go to hydrogen. So we say to other territories, do you want to join us and deploy this network from the south to the north part, from Mediterranean Sea to North Sea, and deploy a network of refueling station using green hydrogen, of course, to decarbonize transportation, heavy transportation? They say yes, and we decide to have a first territory who will be the first one to deploy at this regional scale this network, and after duplicate this model to other territories to have a real large network. The president of Gelmim region said this morning that region are the perfect territories to make experimentation. This is clearly the illustration of this, and we in 2020 start to engage some action in the H2 corridor. The first one was to gather all the stakeholders, the one who will be able to produce green hydrogen, the one who will be able to produce trucks, hydrogen trucks, the one who will use these hydrogen trucks, and all the services and financial you need to deploy that kind of project. And financial was the first step. We had and we received helping from European Union with a subsidy of 14 million euros of subsidy from European Union, and also money from the European Investment Bank with one of the main partners of the project. And we present a project with an objective to deploy 7 refueling stations, very close to the network you present just before, the RTE priority network. 2 renewable production sites in the east part of the project, this close to Toulouse, and the other one close to the port of Port-la-Nouvelle in the Mediterranean Sea. We'll be able to refuel 6 tons per day of hydrogen, green hydrogen, to decarbonize. We have an objective to deploy 40 trucks, 62, I think. Yeah, 62 refrigeration units, because a lot of the trucks crossing these territories are carrying fresh units. Some of them are fruits or other fresh products from Morocco, for example. And the last one is 15 regional interurban buses, coaches precisely, we wanted to develop, and we are engaged to develop. The most important is this project will be working at the beginning of 2025. And the slide, I said the end of 23, but we have a lot of things who move this milestone. And today we are ready to make it working in 2025, because we need to have the production ready, we need to have the carriers ready, and maybe the most important, the industrial manufacturer who manufactures the trucks. There is only maybe 5 or maybe 4 manufacturers able to deliver trucks in this delay. And one of the role a territory and a region can have in this kind of project is to be a coordinator and to be gather the needs and finding the builders, etc., and make this a reality and make sense by producing hydrogen from renewable energy. So this is the Corridor Hydro, one of our flagship project. Thank you very much for your attentions.
Thank you. You see that only with one slide, there should be a lot of information included already there. So, and now to finish, this is, as I promised you, the solution, the approach for a company, and it will be the CEO, Fabrice Anaya, who will be the company NamX, who will present a real solution from this time of the transition. So the last time is for you.
Hello, everyone. I think it's enough. Yes. Wake up. We finish now. So, hello, everyone. I'm Fawzi Anaja, the CEO of NamX, and today I want to explain our vision for hydrogen mobility. As we can see on the picture, we have a car, of course, and just behind a Capex store is a hydrogen distributor of capsule. In fact, the main issue for us when we started NamX in 2017 is that, okay, nice, we will create a new premium car, very nice design, a nice technology, but what about hydrogen network? And the main issue for hydrogen is about hydrogen network. Just for example, you can see on the PDF, we have in Europe 150,000 classic petrol station for only 150 hydrogen station. Of course, there is a big plan to increase this number, but it's not enough. In French, we are only 8 hydrogen stations at 700 bar. So it's a big lack of infrastructure. And if we want to create a new market with hydrogen, we need to create a real network. And so with NamX, in fact, it's a NamX group. We have NamX Automotive with our new car, a new range of car, new premium car. And we have Capex Hydrogen is our solution to provide easier and faster hydrogen to consumer. When we show this innovation at our first world premiere in Italy, we've been in Farina. It was very a huge surprise for people and journalists. But yes, we need to create and to put a lot of innovation if you want to find a real solution for hydrogen mobility. And so this is a capsule of hydrogen, as you can see on the image. In the car, we have 2 types of tank. We have one main tank, like a classic hydrogen car, like a fuel cell car, plus 6 capsules of hydrogen. And with each capsule, we can do between 50 and 60 kilometers. We work on that since 3 years with our best engineers and in automotive and hydrogen. And the reason that we put the capsule on the back design of the car is for the cost of one classic hydrogen station, we can create between 50 and 80 Capex store, 80 hydrogen distributor of capsule. So as we say, the cost is very important reason. The TCO, it's a main point for us, and we should to find a green solution, but of course, a very low-cost solution and a simple solution. So thanks to this innovation, we want to start the SOP start of production of the car in 2027, and 1 year before as an ecosystem of CAPEX. Of course, at the beginning, we have a lot of issue about security, rear crash, of course, but we work on it with best supplier engineers about it. And we think, thanks to this capsule, we can start to create a new hydrogen market. Just for example, with this solution, we have two scenarios. The first scenario, we are on the road and we don't have hydrogen. We can stop on a hydrogen station if we have if we are in LA or in Europe, because California is the biggest hydrogen market. And we can recharge the car in only 4 minutes, and the big tank plus the 6 capsule in the same time. But if we don't have hydrogen station, we will go on the CAPEX store, hydrogen distributor, and swipe a 6 empty capsule with 6 full capsule and go between 250 and 300 kilometers. So it will be a very first important step for us and for hydrogen mobility. But we are very confident about that. We know it's very new, very innovative, but we are sure that in a couple of years we will see that on the road. So thank you a lot, and see you soon. Yes.
So thank you to all you three. I think we have time for one quick question. 5 minutes we have? Okay. So we have one question from the chat. That is a typical question that normally the people are asking. You have? Oh, sorry. Okay. You have? There is another question on the chat? Oh, no. Yeah. Okay. Please.
Thank you for your presentation. So my question is to Mr. Najah. For if there is a battery in the electrical vehicle which are with the fuel cell. So this is the first question. So that can meet the acceleration and deceleration phases. How a fuel cell can meet the courant fort of acceleration, deceleration in these phases. And so if you want to say that is green mobility, so hydrogen should be green. So how you meet these challenges in green hydrogen to charge the tanks? Thank you.
Okay, just first of all, we do not hear your final question, so I will start with the first question. Of course, when we talk about fuel cell vehicle, we have the stack, hydrogen, and we have the battery. For example, for our SUV model, we have 2 versions. The first version and the GTH version is a very powerful car. We are more than 1,550 horsepower. So we have 2 engines, one on the front wheel and one on the rear wheel, plus a battery between 15 and 20 kilowatt-hour, plus the stack, because we need a battery in acceleration and maximal speed. So yes, it's green, but not very green because it's a mix between battery and fuel cell. But we need that to have a very premium car. But at NAMX soon we will announce a big step for us and automotive markets because we work on a new technology on IC engine, and I think it will be very as greener as possible on the markets, more than a battery car, more than fuel cell car. But you know, nobody's perfect, and it's the same things for car or any technology. So we are IC engine for cars. We have fuel cell, and in my point, I think fuel cell will very perfect in 6 or 10 years for automotive markets. And now I think IC engine is better for us. And just to your second question. Okay, okay, of course.
How you can meet this challenge
Okay.
by charging green hydrogen?
At the beginning, our first idea and target is to have only low carbon hydrogen, green, blue, I don't know, pink, but low carbon hydrogen for us. At NAMX, we produce the car, we produce the capsule, but we will buy the hydrogen to a supplier. And now we are in discussion with some partners in Europe, in Africa, to buy green hydrogen or low carbon hydrogen in a couple of years when we will start the production in 3 years. So of course, it's useless if we produce this car, this technology, and we use gray hydrogen. So of course, our objective and the mission is to use low carbon hydrogen for our capsule. And just to finalize, we created a very complete ecosystem for the CAPX ecosystem. We have 3 phases. First phase is between the supplier and us. Second phase is between our capsule distributor and the final consumer. So it's a very big and deep work on logistic costs and security, of course, because you know, if we have just one problem on the market, it will be done for hydrogen. So security is our main and the first point for us. Thank you.
Thank you.
Thank you. So I think our time was finished. So we all are here today and tomorrow. So if any of you have any doubt, we are absolutely free in order to start talking. I will ask you to give a big applause to the panelists, and thank you for being here.